What's up, guys? This is a really cool lesson on polynomial operations, mixing in a little bit of what you've learned in Math 1 and Math 2, and now bringing it to fruition with some interesting challenges. I'm going to show you how to operate on polynomials and how to know that you are right, or know or identify quickly if you've made a mistake, all because we have Desmos right here. So it's foolproof if you learn the formatting. Check this out. All right, let's say I have two functions. I have f of x, a quadratic function, and I have g of x, a linear function. Okay, so abstract question. What would be the value if I take the function f of x and I take away 3 times the function g of x? So the expression f minus 3g. Okay, so check this out. First thing I'm going to do is I'm going to turn this off. So I'm going to type in f of x minus 3g of x because that's my problem. And it's telling me if you take a parabola and you subtract 3 times that linear, you're going to end up with another quadratic function. And it's kind of abstract, but anyway, I've got a parabola right there. All right. Now what I'm going to start doing is I'm going to start substituting equivalent expressions. So f of x is 2x squared plus 5x minus 1. So I write that. And I'm going to take away 3 times g of x, which is x minus 1. Now check this out. When you graph this, if you've just typed in the expression, I wouldn't put any, please do not put any f of x equals or any g of x equals at this point. If I graph that, you can see I get the same parabola. That's really exciting. That means that this has the exact same outputs as f of x minus 3g of x, which means I've written the problem down correctly. So many times we miss problems because we write them down incorrectly. So this is really helpful. All right, essentially we're learning how to work this out on Desmos. All right, after this, I'm going to follow some order of operations. So there's nothing I need to do inside of parentheses. So the first thing that I did is I dropped the parentheses from f of x. All right, that's just 2x squared plus 5x minus 1. The next thing is I have a product. I'm taking -3 and I'm multiplying it to x minus 1. So by distributing -3, I get -3x and then plus 3 because -3 times -1 is positive 3. Check it out again. I'm going to graph this. Surprise, surprise. Same parabola. This means my step is correct. Let's say I would have had something incorrect, like I would have said -3. You have 2 parabolas right there, which means something is not equivalent. Keyword equivalent. All right. But you operate carefully, so you have that equivalent. The last step is really to just combine like terms. And when I do this, I am going to add 5x to -3x, and I get positive 2x. -1 plus 3 is positive 2. And guess what? Once again, I get the same parabola, right? Same parabola, which means that the final answer is 2x squared plus 2x plus 2. That is f of x minus 3g of x. Pretty cool. All right, I'm going to turn off that function. And here's the second challenge. What if I did something, it looks a little more simple, but it's actually a little more complex. What if I take f of x and I multiply it by g of x? Well, apparently, if I multiply them, boom, all of a sudden I've got this cubic function. Makes sense. A quadratic times a linear could be a cubic. I write down my work. That means I wrote it down correctly. 2x squared plus 5x minus 1 times x minus 1. And then what I do is I'm going to distribute my 2x squared to both x and -1. I'm going to do the same with my 5x and my minus 1 term. And I end up with this big old expression. And it turns out it's correct. Next, I combine my like terms, and I'm good. One other perspective that you might consider when you're doing this is you could actually work this out with a box. So I could say 2x squared plus 5x minus 1 multiplied to x minus 1. And I could figure out my products one by one. So 2x squared times x is 2x cubed. You see that's the term that I have. 5x times x is 5x squared. -x, -2x squared, -5x, and positive 1. So that does not look like a 5, but -5x and positive 1. Combine my like terms. I have 2x cubed. 5x squared minus 2x squared gives me 3x squared. Right? Combine your like terms and diagonals. -5x minus x is -6x. Check. And I have a positive 1. That's how I get that result. And again, all of my graphs match up, meaning they are equivalent. That's the lesson. In 5 minutes. Yay.